Today's lesson will be on logarithms! Today's learning goals are to be able to define logarithms, solve real-world problems using logarithms, and learn more about natural logarithms.
It's going to be super fun, so expect to learn a ton of great things. The definition is, logarithms is a quantity representing the power to which a fixed number, the base, must be raised to produce a given number.
This is a graph of log x. As you can see, the vertical asymptote is at x equals to 0. This means that the graph will never touch 0.
A brief history on logarithms. Logarithms was invented independently by John Napier and Jules Berge. They had a similar objective, which was to simplify mathematical calculations. Napier's approach was geometric, whereas Berge's was algebraic, and the logarithms of today is a combination of the two. Natural logarithm, also known as ln x, is log base e. But what is e? E, also known as Euler's number, is approximately 2.71828. It is a rational number, which means it cannot be written as a single fraction. There are many ways of calculating e, however, there is no exact answer. But it has 1 trillion digits of accuracy.
What you just experienced was loudness. The range of intensities that the ear can respond to is so large that it can only be described by logarithms.
Let's learn more! Thanks to our hearing, we can tell that among shouting, talking, and whispering, shouting is the loudest, while whispering is the softest. But how can we prove this? With this formula! Let's solve a problem. Chris doesn't understand library etiquette, so she constantly shouts in the library.
Hey guys!
Shazlin used Alisa as a good example of someone who whispered in the library.
Hi guys!
She wants to explain in mathematical terms because Chris loves mathematics that Chris needs to speak softer in the library.
What is the intensity that Chris should speak in the library? Given that Chris shouts at 90 decibels, Alisa whispers at 30 decibels, and the intensity of Chris's current shouting is 1 times 10 to the power of negative 4.
First, substitute the values into the formula. After subtracting 30 from 90, bring the 10 over to be divided by 60. Exponentiate both sides and bring intensity over to the other side. The intensity that Chris should speak in the library is 1 times 10 to the power of negative 10. But wait, it's not loud enough! Let's do more!
Dang, dang, dang. Have you ever thought about which one is louder? A rocket taking off or the most awesome rock concert of your life? Oops, wrong rocket. Let's hear with the real one.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, fire!
Given that the intensity of the sound of a rocket is 1 times 10 to the power of 4, while the intensity of the sound of a rock concert is 1 times 10 to the power of negative 1, and the decibel of a rock concert is 115 decibels, find the decibel of a rocket taking off!
Extract all the information given. Let the decibel of the rocket be B2, decibel of the rock concert B1, intensity of the sound of the rocket I2, intensity of the sound of the rock concert I1. The value for B1 is 115 dB, I1 1 times 10 equals power of negative 1, I2 1 times 10 power of 4, and let B2 equals to X. After that, substitute all the value into the formula. After substitute all the value into the formula, we will find that the B2, which is the sound of the rocket, is equals to 165 dB. And that's it! Yay!
Very much!
Created using Powtoon.